Hey everybody, MoNaCo here.
And Milks.
And if you hear anybody in the background, that's my son Benjamin. He came to visit for the afternoon, so nice little family affair. We'll see how it goes. We're talking about a couple pages in your packet, 20 and 21. We're talking about some special elements called the diatomic elements and some special forms of elements called allotropes.
Beautiful. Two new vocab words for today. So let's start with some basic definitions. First of all, a molecule is more than one kind of atom, so it's got to be two different atoms, covalently bonded or linked together to form a bigger molecule.
Polyatomic is many of the same element linked together. So you get polyatomic molecules, you get these things like phosphorus and sulfur. You know, you can see in the picture there, phosphorus is the orange triangular kind of shape, and sulfur is this kind of crown shape. That would be a polyatomic molecule because it's multiple elements, multiple atoms connected together.
Right. Okay. Diatomics are very, very special. They exist as two atoms of the same element, covalently bonded together, and across the top you can see who they are.
1, 2, 3, 4, 5, 6, 7. Seven of them. Hydrogen,
nitrogen,
oxygen,
chlorine, bromine,
and iodine. These are the ones that exist in pairs, like Siamese twins, I'd call
right.
them.
So unless they're in a combination with something else completely to form a molecule, if you're going to find oxygen, you're going to always find it as O2. It'll never exist by itself as one single atom. That's what makes them so special and unique.
Yeah. So that's why we call them diatomic molecular elements.
Right.
And a way to remember them is Hofbrinkel.
Right, that's an acronym.
It's an acronym, yep. Some of us say, oh, that was the name of Einstein's dog, Hofbrinkel.
Yeah, I always wanted him to name his dog Hofbrinkel.
But it's really just Hofbrincl.
Right. And the other way is what's called the 7H club. And if you look up at the periodic table above, you'll see that those purple elements form a 7 and an H.
Yeah, that's a really easy way to remember it.
So these are the diatomics. Do you think you need to know them?
Yeah.
Yeah.
Most definitely.
Most definitely.
And the cool thing about the next little piece that we're going to talk about is phosphorus, sulfur, and selenium all form allotropes, which are not diatomics, but they make different forms of the same other things. So to ask the question, why can't the diatomic elements exist alone or unpaired by themselves? Mr. Milks, what do you think?
I think it has a lot to do with their valence electrons and how reactive they are, and they need to form bonds to become stable.
Yep. Absolutely. Hydrogen needs to form one bond, nitrogen needs to form 3, oxygen needs to form 2. And what better way to do it than to find somebody else who's got to do the same exact thing and share?
There you go.
That is what it is.
It is. So now we're going to move on to allotropes. Definition of allotrope is one of two or more forms of an element, non-metal specifically, in the same phase, but with different formulas and hence different physical or chemical properties. Formulas means like how many.
Right. Like
how many form that one kind of molecule or polyatomic.
The perfect example that we're all using right now, I hope, is carbon, but there's some other ones too. You've heard of oxygen. We're breathing it in right now. It's keeping us alive. There's an allotrope of oxygen. It's called ozone.
Sure, and isn't there a problem with our ozone?
It's not as bad as it used to be.
It's getting better.
Right, but the problem is that we have an ozone layer that protects all the organisms on this planet from harmful ultraviolet radiation.
Sure.
So one form of oxygen sustains our life. Other form of oxygen gives us protection on the planet from ultraviolet radiation.
Sure.
The other type of allotropes are carbon.
Carbon. So the graphite in your pencil, it's not lead. It's actually carbon graphite and diamonds.
As well as charcoal, like cooking out a barbecue.
Sure.
All three of them are made out of carbon.
Right. Or the coal for the coal-fired plants where they make electricity.
Right. Charcoal, coal, diamond, and graphite. All made out of carbon. But the way
different structures, different. In order to get diamonds, you got to have an immense amount of heat and pressure on that same carbon, and we'll make it.
Yeah. So some special elements. Here's another version, some more allotropes. We're talking about phosphorus, this one. There's 3 forms of phosphorus, red, white, and black. They're only containing phosphorus. The white phosphorus is this triangular arrangement of it. The red phosphorus is kind of like this longer network, kind of a funky kind of up and down kind of situation. And the black phosphorus is like sheets, okay, of different forms. So they're all made of just phosphorus atoms connected together in bonds, but the way that they're connected together makes the different forms, different colors, reactivities, and melting points.
There you go.
Yeah. White phosphorus is actually really dangerous and explosive. Black phosphorus is really stable and not. Red phosphorus is what you commonly find at the tip of a match. It's strike it hard enough, it bursts into flame.
Right.
Black phosphorus won't do that because it's super stable. White phosphorus, you expose it to air, it's a fire you can't put out.
Right. That's fun. Well, maybe not.
And notice the melting points kind of reflect that. Melting point of 44 degrees Celsius for white phosphorus means that it's probably pretty volatile.
Yeah, room temperature is about
Yeah.
25. So
Right, so you
not-
heat it up a little bit and it
It's
turns
going.
into a gas and boom, kapow, zip, zang,
Yep, there it goes.
explosive.
So we need to know what diatomics are, who they are.
What are they again?
Hofbrinkel.
Yep, who's he?
Hofbrinkel is the acronym for which elements are diatomic: hydrogen, oxygen, fluorine, bromine, iodine, nitrogen, chlorine. Hofbrinkel.
Yep.
What's the other way to remember it?
The 7H club, because they make the shape of a 7 on the periodic table.
Right, and then throw hydrogen in, it makes the
Right.
7H club.
Mm-hmm.
Got it.
And what is that allotropes?
Allotropes, different arrangements
Of the same stuff.
of the same stuff, the same kind of element. Different arrangements of it give it different properties.
We had isotope,
And now we have
allotrope. Isotope, same element, different neutrons. Allotrope, same element, different structure.
Nice.
Got it. That's now the words kind of make sense now.
Well,
A
the
little
rhyme
more.
or reason to the science stuff?
Rhymes and reasons?
Where is Rhymer anyways?
Oh, she left.
Okay. Hey, it's great seeing you guys. See you
Thanks,
guys tomorrow in
everybody.
class.
See ya.